Hello students, welcome back to maths class. So some more problems left in our exercise. So today we will solve one long question, most repeated long question, 7 marks question, right? So already I said to you, whenever problem is in complex form, right, a square root form, right, we will simplify it into simple form, then we will differentiate. Actually, one more thing is, this is prove that problem. So at the end you will know whether you got your correct answer or not. With that you will know whether you are getting 7 marks or not, isn't it? So actually in mathematics, whenever we got prove that, show that problem, some advantage is there. Before solving the problem, you will know the answer, and at the end you can check your answer. If something, if we got differently, we can check once again from the beginning, isn't it? So, and observe, this is the given problem to you, right? So we have to prove that dy by dx is equal to root of 1 minus y square by root of 1 minus x square. Okay, so here if you observe the problem, so many square roots, so it is in complex form, so we have to go for substitution. So come on, how we can take the substitution here? So you take, put x is equal to sine theta, okay, and y is equal to sine pi, right? We are having two values here, root of 1 minus x square is there, root of 1 minus y square is there. So we can take x is equal to sine theta and y is equal to sine pi. Now substitute in the given question. What is your given question? It is root of 1 minus x square plus root of 1 minus y square is equal to a into x minus y. Okay, so we can substitute the values here is equal to root of 1 minus x square. X means we can take that value as sine square theta plus root of 1 minus y square, that is 1 minus sine square phi is equal to a into x minus y. How we can take x minus y? We can take sine theta minus sine phi. Okay, so now this is 1 minus sine square theta. By our identity and by our trigonometry, we can write this as cos square theta plus root of 1 minus sine square pi. Again same thing, same formula is repeated. So it is cos square pi is equal to a into sine theta minus sine pi. Okay, so here square root will get cancelled. Now your problem is in the form of cos theta plus cos phi, right, is equal to a into sine theta minus sine phi. Again go to trigonometry. Actually observe carefully, while doing our substitution problems we are using lot of trigonometric formulas. So if you are familiar with the trigonometric formulas, then only we can solve our substitution problems properly. So both are having equal importance, A as well as B. If you are perfect with A, you can solve B problems. If you are perfect with B, you can solve A problems. They are interconnected. See how many trigonometric formulas we are using while solving differentiation. That too calculus we are doing, but we are using lot of trigonometric formulas. So come on, now come to what are the formulas. This here we got, this is cos C plus cos D. Okay, so cos C plus cos D is equal to, it is 2 cos of C plus D by 2 into cos C minus D by 2. Similarly, here we are having sin C minus sin D form. So sin C minus sin D is equal to, it is 2 cos of C plus D by 2 into, it is sin C minus D by 2. These are the two formulas we are going to use here. Why? They are in that form. That's why instead of C and D, we are having theta phi, isn't it? So apply those formulas. How we will apply? Come on, we can write 2 cos of theta plus pi by 2 into, what is that? Cos of theta minus pi by 2 is equal to A into sin C minus sin D. We can write this as 2 cos of theta plus pi by 2 into sin of theta minus pi by 2. Okay, so this is our formula. By applying the trigonometric formulas, we got these two formulas. Okay, so come on, this one 2 also cancel, and cos theta plus pi by 2, both sides on equation, both sides, so we can cancel them. Now what happens? Bring this A this side 1 by A and send this cos to other side. What happens? It is sin of theta minus pi by 2 by cos. We are sending, here it is multiplying. If you send that side, it will divide. Cos of theta minus pi by 2. So is equal to sin by cos. It is a tan, right? So it is tan of theta minus pi by 2. So 1 by A is equal to tan of theta minus pi by 2. Send tan this side. What happens? It becomes inverse, right? So it is tan inverse of 1 by A is equal to, it is theta minus pi by 2. Okay, take 2 also this side. What happens? 2 into tan inverse of 1 by A is equal to theta minus pi. You bring this pi to this side, then it will be theta minus 2 tan inverse 1 by A. So, but what is our pi and theta? In the beginning, we have taken x is equal to sin theta. With that, you can get your theta. How? Just send sin this side. If we send the other side, what happens? It becomes inverse. Okay. Similarly, here also we want pi. So, send sin this side. It becomes inverse. So, it is sin inverse of y is equal to pi. So, here in place of pi, we will write its value as sin inverse of y is equal to, in theta place, we will write it is sin inverse of x minus 2 tan inverse of 1 by A. Observe, this is y function, this is x function, but this is 1 by A. It is a constant function. There is no variable at all. This totally is a constant function. Tan inverse of 1 by x, then variable will be there. We can differentiate it. So now differentiate with respect to x on both sides. With respect to x on both sides, we have to differentiate. So what happens? D by dx of sin inverse of y is equal to d by dx of, we are having two terms, isn't it? Sin inverse of x minus 2 tan inverse of 1 by A. So whenever plus minus, we have to take separate derivatives. So it is d by dx of sin inverse x minus d by dx of 2 tan inverse of 1 by A. So this side, d by dx of sin inverse y, it is standard form. Did you remember what is the formula? D by dx of sin inverse y is equal to 1 by root of 1 minus y square into d by dx of that variable. That variable is y here. Generally we will take d by dx of sin inverse x. There your formula is 1 by root of 1 minus x square into d by dx of x. D by dx of x is 1. That's why we will take only 1 by root of 1 minus x square. But here it is y. Function is in terms of y. So, d by dx of sine inverse y is 1 by root of 1 minus y square into d by dx of y will be there. Remember that point, that is very important in this problem. Okay. So, 1 by root of 1 minus y square into dy by dx is equal to, this is our standard form, d by dx of sine inverse x is 1 by root of 1 minus x square. No problem with this function, but be careful with this function, it is danger function. Y means it is in terms of y. Whenever function is in terms of y, d by dx of y we have to write. Actually, where if function is in terms of x, no need to write d by dx of x. Why? D by dx of x is 1. 1 into something means something only. So, if we are not taking that d by dx of x, then also it is okay. But if function is in terms of y, we have to write that d by dx of y. Okay? Remember this point, minus and d by dx of tan inverse of, it is not in variable form. Tan inverse of some constant is there. So, entire function will be constant. So, derivative of constant will be 0, right. So, is equal to, it is 1 by root of 1 minus x square. So, we want only dy by dx. So, send this value that side, dy by dx is equal to, come on, it is root of 1 minus y square by 1 minus x square. That is the answer of your problem. So, very simple. Actually, you can enjoy with these differentiation. Calculus is very interesting subject, interesting topic in mathematics, not only in intermediate, right? It will continue, right, in a degree, in engineering, right? In so many fields we will use this calculus, okay? So, in science fields. So, now observe when this problem, how we have to solve this problem means, if root of 1 minus x square plus root of 1 minus y square is equal to a into x minus 5. So, problem is in little bit complex form, square roots are there, that too 2 times are there, and inside the square root again x square is there, y square is there, so many functions are there. So, whenever it is like that, we will go for substitution. Instead of values, we will substitute something and we will simplify. So, see, actually in these problems, most of the problem will be in simplification only. Till here we simplified only, isn't it? Up to here we simplified the problem. After that we started our differentiation. Okay, in substitution problem, most of the problem will be on simplification only. We will substitute some value and we will simplify. After getting that simplified, simple value, we will differentiate it, right? With that, we will get our required answer. See, what is the question? Prove that dy by dx is equal to root of 1 minus y square by 1 minus x square. So, at the end, you will know whether you got the answer or not in this proof that show that problems. So, come to this, how we solved. Here, this is in complex form. That's why we went for substitution method. So, first put x is equal to sin theta and y is equal to sin pi. We have taken. So, send this sine to this side, you will get your theta. Whenever we send sin, tan, cos, tan, all these things, secant, anything, this side it becomes inverse. So, sin inverse of x is equal to theta, sin inverse of y is equal to pi. After that, you take your original question, what is that? Root of 1 minus x square plus root of 1 minus y square is equal to a into x minus y. In x place, you take your sin theta, in y place, you take your sin phi. So, what happens? It is 1 minus sin square theta. So, we know that trigonometry identity, right? Sin square theta plus cos square theta is equal to 1. So, 1 minus sin square theta is cos square theta. We applied that same formula here. So, square root will get cancel. Now if you observe this problem, what happens? It is cos C plus cos D form, and here it is sin C minus sin D form. So trigonometric formulas, right? So there is formula in trigonometry cos C plus cos D, then we can take that value as 2 cos of C plus D by 2, cos of C minus D by 2. Similarly, sin C minus sin D can be taken as 2 cos of C plus D by 2, sin of C minus D by 2. These are the formulas. Okay, if you write 2-3 times, you will get familiar with the formulae. So again, formulas means general form. Instead of C and D, we can have any two values. So here you are having theta phi. Instead of C and D, we are having theta pi. Here also theta pi. So we applied that formulae. Okay, after that both sides 2 cancel, and cos of theta plus pi by 2, cos of theta plus pi by 2 both cancelled. Okay, so if we cancel, what is the leftover value? Cos of this is equal to a into sin of this value. So 1 by a is equal to, this can be written as sin of theta minus pi by 2 by cos of theta minus pi by 2. Sin by cos, what is that? It is a tan of theta minus pi by 2. Okay, so send tan to this side. Tan inverse of 1 by a is equal to theta minus pi by 2. Send 2 also this side. Why we are doing all these things? At the end, our aim is to get dy by dx values. That means slowly we want to write the values in terms of x and y. Then only we can get dy by dx. For that sake, send 2 this side. It will be 2 tan inverse 1 by a is equal to theta minus pi. Bring that minus pi this side, it will be plus, right? Pi is equal to theta minus 2 tan inverse 1 by a. Now in the beginning we have taken x is equal to tan theta. With that we will know our theta. Similarly, we have taken y is equal to sin phi. With that we can get our pi. So substitute those values. So till now it is only simplification. We simplified the complex problem into some standard formulae form. Now you observe sin inverse, tan inverse. Yes, we can differentiate it. Actually, differentiating the given problem is very complex form. Now we converted that complex form into simple form by using our substitution method. So now we can easily, we are having standard formulas in differentiation. Whenever it is like this, then we will differentiate with respect to x on both sides. So d by dx of this. So whenever y function is there, d by dx of sin inverse y is 1 by root of 1 minus y square into dy by dx will be there. Okay, so similarly, right, so if we take with respect to x, there also it will be d by dx of x will be there, but d by dx of x is 1 into something means something. That's why while giving the formulas it is not mentioned, right? D by dx of x is not mentioned, but it should be understood. Okay, so here d by dx of sin inverse x is d by dx of sin inverse x into d by dx of x will be there. It is 1 into this one means this one only. So next here d by dx of this function is not in terms of x, it is in terms of constant. So derivative of constant is 0, right? And here 1 by root of 1 minus x square. So we want only dy by dx, we don't want this one. Send this value to the other side, you will get the answer. Okay, most repeated 7 marks question. Be careful, right? Practice 2-3 times if you are not getting. Actually, after, if you are attentive in the class, if you listen the full cassette, right, full video from the beginning to ending, one time practice is enough. You will copy one time, then you will practice. So that is enough for you if you are attentive. Otherwise, blindly you are doing, if you practice 5 times, 6 times, then also no use. So be attentive while explanation is going on. Don't by heart it, right? Understand the steps when we will use a substitution, how we simplified the problem into simple form. Once it is in simple form, then we have taken differentiation. Like that, you should get the logic of the problem. Okay, don't by heart blindly. Okay, so practice this problem. Okay, 7 marks problem, most repeated 7 marks problem. If you see in your material or in your any model paper, so many times, almost 7-8 times repeated question this one. So most repeated question, don't neglect it. Okay, practice this problem. That's all for today. Have a nice day.